All right, let's take a look at each of these examples here really quickly. In the first one, again, the restricted portion is this fraction, the denominator. So you have to set that equal to 0 and find any restrictions. So our domain is going to be all real numbers, as long as x does not equal what value? 2. So when you write this, r comma x not equal to 2 is how you would enter this online. That's the only restricted value for that expression. In the second example, it's an even index radical. Now, if this had been a cube root, would there be any domain restrictions? No. A fifth root, no. Any odd index, there's no additional restrictions. But for an even index, your expression has to be a non-negative. So we set it greater than or equal to 0, which means x has to be greater than or equal to -2. And so there's our domain, all real numbers, x greater than or equal to -2. And so we can express this either in the inequality form, or we can express it in the form of an interval notation, where -2 is our lower limit, infinity is our upper limit, infinity can never be reached, -2 is included, so there is a bracket there. And then finally, in this last example, our limiting factor is the denominator of the fraction. And so if you look to factor this, does this factor into x plus 1 times x plus 1? No. Okay. A lot of you made this mistake on the Chapter 3 quiz. The problem was x squared plus 9. Okay. And a lot of people wrote x plus 3 quantity squared. Okay. Be very careful with that. When you have a squared plus b squared, the sum of squares is considered to be irreducible across the reals. You can factor it in imaginary numbers, okay, but not in the real number system. So be very careful on that. The difference of squares is factorable. The sum and difference of cubes is factorable, but not the sum of squares. Okay, so in this case, all we're left with is that expression, x squared plus 1. That's our one limiting factor. Okay? And so when you look at it, is there any way that we can set this equal to 0 ever? Can x squared ever equal a -1? No. Because of that, there's no restrictions on the domain. So your domain is just going to be all real numbers. So you can express that either with a capital R by itself, or in the interval notation, -infinity to +infinity represents all real numbers.